Yeah, okay. So this is Coffee Compiler Club. Everything and anything about compilers, garbage collection, language runtime, code gen, any of that kind of stuff, typing systems, anyone's language rants, make systems and the likes, all fair game. I record these, you're live. The video will go up on YouTube and Twitter a couple hours afterwards. If you don't like that, bail out. You know, I reserve the right to moderate. I never had to do it. Otherwise, it's open mic. Don't raise your hand, just come out and say something. And I tend to run on, and I sometimes stomp over people, and I apologize when I do that. And you know, it's just a work in progress for me. Feel free to run on back at me until I get a clue that you're saying something different than what I'm talking over. It happens. And after that, okay, that's done with spiel. So it's whatever people want to talk about, other than haircuts, which I think we already covered. And I'll throw out, how do I think this through? Throw out more type system theory things if people are interested, but you have to ask and not.
I'm curious, you know, I know, for example, what Arthur works on. Trolls, what do you work on?
I'm a researcher. I work on compilation of functional languages to parallel hardware, in particular GPUs and such.
Oh, very cool.
Yeah, so not so much just in time. I work on big and slow ahead of time compilers.
Are you doing functional on GPUs?
Yes. Well, it's more we were doing functional programming and then trying to compile it to parallel code. But GPUs were our initial and most interesting target because they are difficult to program. So there's more to gain.
Yeah, I'm asking, are you doing side effects?
No side effects. Pure function programming. I mean, all down to basics.
Okay.
So I mean, when I was an undergrad, which is many years ago, I was told that functional programming would be the future because the future was going to be parallel. But it's a future now. I don't think functional programming has really taken over parallel programming. People do that in low-level languages because it has to be fast. Otherwise, why do parallel programming?
Maybe why do parallel, exactly.
Yeah, and so I spent most of my PhD looking at why functional programming hasn't taken over the world of parallel programming. And it just looks like there's too much stuff in functional languages for them to run fast. I mean, yes. If you need fully first-class functions, that, I mean, at least on a GPU, that's not going to fly. So we try to cut it down to the basics and see, well, I mean, the fundamental bones, are they good enough? I mean, is there something there that's worth using? And yeah, unsurprisingly, there is, but you have to sacrifice a lot of what makes normal functional languages nice to use. So it's a kind of a trade-off.
What's your base language? Are you doing like Haskell or ML or something?
No, it's kind of a least common denominator ML, where we take away the stuff that we don't think you can compile to efficient code.
Right.
But just your basic, strictly evaluated ML-like language with some restrictions on how you can use higher order functions.
No monads or side effects?
Well, you can always encode monads, but no side effects.
Right, but you encoded monads and you bake them down to something reasonably efficient, which I guess I'm asking, are you doing update in place in CodeGen?
Okay, so that's yes, we are doing that in CodeGen, and we also realize you do kind of need it in the language level. But unrestricted side effects are kind of madness when you want to generate parallel code, unless you want it to be up to the user, not to screw up. So we actually found some theory about uniqueness types, which allows you to do in-place updates of arrays, which is what I mean, of structures, because variables don't really matter necessarily anyway, and still have functional guarantees. You're basically saying, okay, when you update an array in place, you promise never to use the old array again, and the type checker will check that. Then you can kind of just do it.
Linear logic?
Yeah, exactly. Well, it's not exactly, because linear logic, you have to use things exactly once. Uniqueness types are kind of different. You can throw things away, that's fine. That's a reference counting for memory and so on. You're not responsible for freeing things yourself, but it is very inspired by linear and affine logics.
Okay, so it's not, okay. It's not a linear logic. It's
no.
Okay. That's
yeah, linear logics are mostly for resource management, aren't they?
Well, a resource would be you have a fixed amount of memory in your GPU and you want to update in place because.
Right, but yeah, but linear logic, that's about, I mean, things like file descriptors where you want to make sure someone closes this file eventually, or someone frees this memory.
That's one side of it, but another side is simply to say, I have a large array. I want to know that I'm done with its current value at the end of this bulk array operator so that I can put my answer right back in the same array where it came from.
Yeah,
So
I guess, but
I don't have to have two such arrays, a source and a dest, and I don't have a fixed memory pool on the GPU and I'm out. I mean, that was my obvious take on where you would apply here.
Yeah, I think you can use linear logic as well, but we found uniqueness types, which are, I think that was from a language called Clean from the early 90s, which took a non-monad approach to handling I/O in a pure language. And it seems like that's simpler if you just want in-place updates.
We need somebody to throw in the link here, because I think I'm pretty aware of linear logic. I'm not so clear on the distinction with.
Trolls, I didn't, I'm not sure if you said it. Where do you work?
At the University of Copenhagen.
Cool.
I'm a postdoc there.
There's a lot of introduction to linear logic.
Yeah.
There's wiki articles on it. I'd say Clean from the 90s. I remember the Clean name. I never messed with it.
Yeah, Clean was one of the, you can kind of say Haskell competitors. I mean, this is before my time, but.
Okay.
Yeah, Haskell won. I'm not quite sure why. Clean is still around, but it's not nearly as big.
Right. Well, it's around because somebody who invented it loved it, and so they kept it alive.
Yeah, sure.
I don't know, but this is sort of the general rule is there's an author, he's in love, so it's alive.
No, it looks like a perfectly decent language.
Okay, and then he makes all his grad students write all their papers in it.
Yes, I was actually at a conference recently where someone was giving a presentation of some function programming stuff, and it looked like Haskell, but it was kind of weird. There was these weird syntax errors all over the place, and eventually I realized, oh, this must be Clean. I mean, it's very, very similar, but it's just different enough. It's like a C# Java thing. Well, probably slightly more different, but yeah.
Okay. Yeah, if you get a link to it, I'd be interested in the logic piece, the unique logic types, because I'm curious to see what the distinction is. Cameron, you're just your body's fading in and out. Detached head state. All right, this is whatever Max Headroom from the 80s or something, right?
I got to be more careful with my clothing choices.
Okay.
I guess I'm kind of curious how you are talking to the GPU. Are you using some kind of framework to do this, or does the GPU have an SDK you're using?
We are targeting OpenShell and CUDA. CUDA, I should say, so you can choose. Let me just see if I can find some of those uniqueness types. I remember I read one paper originally that was kind of.
But you're using them internally.
Yeah, it's not visible to the user. Yeah, I mean, it's compiler, so you run it, and then it generates a C program that then contains calls to either OpenShell or CUDA.
Right.
Yeah, so you're basically translating to C or CUDA C.
Yes.
Okay.
Right, but I'm saying your core compiler tech is using uniqueness types, which I'm curious for the link for. Yeah.
Yeah, well, it's just kind of an you could remove it without really changing the big picture much. And to be honest, if I would have liked to remove it because uniqueness types are kind of difficult to maintain in an optimizing compiler because they have this kind of correctness of a transformation in the presence of uniqueness types, or specifically in the presence of in-place updates, can be kind of non-local because you have aliasing.
Yeah.
And when you update an array, you need to make sure that neither that array nor any of its aliases will be used on any execution path following that. Otherwise, it would be a type error.
Right. Okay.
So it's kind of that's kind of tricky to maintain for some kinds of optimizations because you have this kind of non-local correctness.
Well, as soon as you allow aliasing, and then you have to go track it down, life gets more.
Yeah, but in a function language, usually it's not a problem. You can just alias everything. It doesn't matter because you can't do in-place updates.
In graph rewrite systems, I can count the number of papers talking about graph rewrite systems for compiler work in like one hand. I guess if you don't count lambda calculus, which fine.
You have to count lambda calculus here, I'm afraid.
Yeah, okay, fair enough. Wow. Okay, fine. I'll stare at it some more offline. So just reading,
Yeah,
reading for the day.
It's kind of dense, and it's kind of a different evolutionary path with respect to how you encode effects in functional languages than the way the world went, because the world went with monads and effect systems instead. And my impression, which is mostly just a gut feeling, is that uniqueness types are really, really nice. I mean, they kind of have very human friendly semantics and rules, but they are not very flexible. You can do just a few things with them, whereas monads are more complicated conceptually, but you can do many more different things. So you get better return on investment. And things like effect systems, well, we'll see. I don't think they really exist in anything remotely mainstream yet, but they are even more flexible.
Okay. Yeah. Fair enough.
But I'm not really a type theoretician, so.
Yeah, I'm not either. I stop at like short of denotational semantics. I read these things. I kind of have the intuition, but I don't do denotational. On the other hand, the paper looks entirely readable. It gets into typing theory down below. That's going to be less readable. Fine.
Yeah.
Well, I'll double Cameron's question. Paul Hohensee, what are you working on?
You guys know each other, right?
From a long
time ago.
Yeah.
Nothing very special. Mostly I'm working on update releases, doing backports and fixing bugs for other people. Right now, thing I'm doing is actually serviceability, changing the memory pools for G1 from the two of them they have now to a bunch. I'm looking at old gen, Eden, Humongous, Free, and Archive. There's 5 of them.
And you have to hack each individually?
Well, you have to, yeah, so I have to define what they are and get JMX plugged into them. It's not like hugely complicated, but it's a lot more reflective of what G1 actually does than the current, here's the Eden, the survivor space, I forgot one, Eden survivor space and old gen. Especially adding, free as a memory pool.
What do you mean by
free regions, right? It's just they're all address-wise disjoint. And if you want to know what's free, you just say, hey, free, free memory pool current. Or used, I guess, is what the property is.
Gotcha.
Yeah. So nothing to do with compilers that much.
No, I dealt with the Zool collector plenty.
Yeah. So Gil's actually talked to us. There's a bunch of M beans, right? MX beans you guys have built. He wants to merge those into OpenJDK, which actually doesn't look terribly hard. You're basically extending existing data structures and changing the resolution of timers. I think your MBeans use floating point, and you could just as well use microseconds or something. Or use nanotime or something in the background. So it's not hard, it's just work.
Yep. Well, Zool played a bunch to high frequency traders.
Yep.
And GC, so counting nanotimes was actually business model. Yeah.
And now with Shenandoah and ZGC, we're back to needing that. I don't know where C4 is going to go. Hasn't been open sourced. It's going to get superseded if it's not open sourced really quick, I think.
I took my payout from Azul and I'm done.
Yeah, great gathered.
They get to figure themselves out now.
Yep, they're doing well, I hear.
Yeah, well,
All due to Oracle.
the reason I got a buyout was they were doing well. Somebody decided to pay out.
Yeah.
Well, it's nice when Oracle establishes a business in a particular market and sets the price so high that 50 companies could be profitable at a fraction of that price. So, so introducing paid Java support as a major item really opened up the market for companies like Azul. And there's another one, Paul. You probably know a lot of the people there in is it St. Petersburg? A lot of ex.
Yeah, Belsoft.
Yeah, that's the one.
Yeah, you know those guys.
Yeah.
The small world.
Small world.
It's basically former St. Petersburg Oracle office. Like they have quite a bit of
Yeah.
on there.
Yeah.
In St. Petersburg?
Yeah.
Yep.
Yes. I was there twice last year.
You should go see those guys.
If I had
Just
known,
drop in.
I'd have come knock at their door. That'd have been fun. Wow, that's a small world. It's unlikely I'm going to get back there anytime soon, though.
No, right. They won't let anybody in from the U.S.
Well, with good reason. Holy shit. Crazy ass thing. It's my usual, entertainment budget is to go travel.
Mm-hmm.
And that's all shut down. Go camp, all shut down. I guess camping's starting to open up. We had wildfires cut down all camping in California for a month.
Yeah, you got to go out of state for sure.
Yeah, well, that's a 5-hour drive.
Right, it's a big place.
Suddenly it went from 1.5 to get onto Big Sur and coastal redwoods and ocean to 5 hours for Nevada desert. Oh.
Right. Exactly.
Have you guys outlawed gender reveal parties now that one of them burned down half your state?
You can't outlaw people.
So
you can't outlaw stupidity.
So is this Adam's first time on the call?
Well, then we should ask Adam what the hell you're doing for your life.
Fill us in, Adam.
It's not my first time on the call, but my interest is mostly sort of historical. I'm at Uber these days, and I work mostly on tooling around sort of PL, like large scale code transformations, bug finding, performance optimizations, but not so much sort of runtime or compiler stuff anymore. But historically, I worked with Brandon at Oracle. I was on the sort of the large Graal VM team. I worked with Paul a little bit. While both of us have been at Adobe a long time ago. So I have a lot of interest in the programming language implementation. I'm just not doing this these days as such, but Brandon has asked if I want to join the group as interesting things are being discussed, and I was like, sure. So that's why I'm here.
There you go. Well, it's a random conversation, so it sometimes
which is perfect for me.
Okay. Sometimes we talk about haircuts and wildfires, and sometimes we talk about lattice theory and typing systems.
Yeah, so this is like my third meeting that I joined, and it's been fun. So thank you.
Zen, I'm still, by the way, just looking for a conversation opener that gets going here. What did you ever get your broken graph figured out? I thought more about what you spoke of last go round, and I had an idea. Are you on the call? Yeah. No sound. Your mic is on and there's no sound. Your mic is off. Zen, you're muted, I think. On your end, or we have no sound from you, Zen. So I think you have a mic issue. Well, why don't you sort that out? And you can just blast in when you get your mic figured out, and we'll do something else.
So, Cliff, I actually have a question. Like, I don't know if it's a good for opener, but since I was on the Graal team, but I wasn't on the core compiler team. I was actually implementing some of the languages on top of the infrastructure. But I was wondering what your opinion is on this project. I mean, it's a large project now. They moved to sort of productize it, so it's kind of part of the JDK release. But did you have a chance to look at this compiler and its implementation? And believe me, I have no sentiment towards the team. So you want to be critical, please be. I'm just curious. I mean, since you have so much experience with C2, how do you compare these? Do you think it makes sense, or it made sense to?
Right. I get this question. I get this question asked every time I go to a conference. And Cameron, your new background is hella distracting. You have little blue worms crawling under your head around mushrooms. This is not copacetic for a casual conversation or something. Yeah.
It is disturbing.
Yeah. It's a little disturbing too. Your head's growing out of the ground with mushrooms and little blue worms.
It looks like some sci-fi movie weird thing.
Right. There you go. There's another one.
Hello.
Hey, Zen, you came back in.
Hello, can you hear me?
I can hear you now, Zen.
Okay, actually, I partially solved the problem. I managed to fix the problem in like a brute force. In brute force, I mean, very violently cut off the some edges to make sure that if you got chance, probably you can take a look at this draft PR. I just sent a couple minutes ago, and yes, I filed a GBS issue about this one, but this one is not so perfect because it's still based on the API level. You can see that I put those optimization in the string optimization to follow the current coding style, and I'm still working on that. I hope that we can make it better. I mean, I can make it like a more general solution.
I'm looking for where the damn, oh, there it goes. Fine. I'll stare in a second because I'm sort of you're doing it at the API level, sort of not really a C2 hack. I mean, it is, but it's not. I would still claim totally the wrong way to go.
Yeah, I know that. I just want to make it like a proof of concept and move forward to like a lower level. So I'm working on that.
Okay. Yeah. Wow. Yeah.
I have some on working in progress patch about like
that's pretty ugly there.
C of node.
You're optimized for substring. What was the other one here? Eliminate call. That's getting ugly. All right. Let me not stare at that right now. Adam, I'm going to answer Adam's question because we were in a conversation with Adam when you piled in and finally get your mic working. So the question about Graal, I get asked it every time. Not every. 90%, right? I stand up in front of an audience. What do you know about Graal? So I stock answer, right? So C2's 25 years old. As optimizing compilers go, it's long in the tooth. I would have thought it would have been superseded a long time ago. It hasn't. Graal folks have been at it for a long time as well. Graal is not a new tech by any means. And I would have thought they would have caught up to C2 a long time ago, and they did not. And it's only in the last year or two that they are making sort of reasonably, reliably repeatable claims that they are as performant or more performant on a broad set of benchmarks, but they're clearly not enough more performant to be terribly exciting. And they have known potholes where they fall down that C2 got ironed out long ago. So as a user of a JVM in a production setting, if there's a new technology that comes along and it doesn't directly address a problem I have, I'm not terribly inclined to grab it because you have to suffer through all the new technology warts for no gain. If there's something that Graal does, and there are some things it does better than C2, if there's something that Graal does that I want, say, better escape analysis for Scala execution, then maybe I'm more excited. That being said, they should keep plowing on and they'll get to the point where it makes sense maybe to flip the code base from C2 to Graal.
So
I think they're not there yet from a high level. I think they're closer than they've been. I think they've been working on it for a long time. I'm not holding my breath. I'm encouraging both sides here. I like, okay, C2 should add escape analysis or a better escape analysis.
Isn't Graal mostly supposed to power those partially evaluated interpreters?
That was where they came from. It's like one of the subpieces, like truffle or something, starts there. But no, Graal is a full-blown optimizing compiler, and with the Graal folks' mindset being that they're going to replace C2. But the actual behavior is it's not as fast as C2, but it's getting close. And not as fast, meaning for a long time they were asymptotically underneath. Now they can be occasionally above or occasionally below. And on all the benchmarks that they've carefully targeted, they're definitely above. And not by a huge amount, but they're above. That's good. But if you look at a broader spectrum of things, then they're like all over the place because they hit potholes where they suck in C2.
Well, they have a really basic problem, which is local code generation. They don't have a bottom-up rewriting system, pattern matching code generator. It's just like C1.
Oh, really?
CNO generate code.
So why would they expect Graal to be faster than C2? I mean, because they're not just assuming they can just do it better without having some trick, right?
So C2 is a graph. Sorry, Paul, but just say C2 is a graph rewriting engine as its core optimization. Plus, it does the classic C Fortran compiler optimizations of doing things with loops, and then it has a much better register allocator. Okay, fine. I thought Graal came in with a graph rewriting engine written in Java instead of in C. So it'd be a lot easier to maintain and deal with. The actual core tech of doing graph rewriting can easily be done in Java. But if their backend isn't producing well-generated local code, they're never going to catch up. I didn't know that, Paul. Sorry. So go ahead, Paul.
Yeah. So also, I've heard from various people that have worked on Graal. Some people say, "Oh, this is easy," but they tend to be junior people. The senior compiler writers say this is hard.
Okay.
Harder than C2 in some respects. We have people who have experience with both of them.
Really?
I think it's just that compilers are irreducibly complex. It kind of doesn't matter what language you implement the sucker in.
Now there's the thing there, yeah.
Yeah. Also, near as I can tell, the two things that Graal does that C2 doesn't are they do much better inlining. And you can see some of it in Graal CE, but most of that's proprietary in EE. But there is a paper on it, so it can be done.
Yeah, I think the reason Graal exists though is because you reach a point of complexity at which it's easier to rewrite something than to change it.
Yeah,
I have a different piece of color.
I do too, but go ahead.
So I walked into Sun, and Robert Grismer and a couple other guys from the Self team from Europe had written a first round code gen. And I looked at that and said, that'll never ever make good code. And they looked at me and were like, you know what the fuck you're talking about, but not quite such words, but back in that era I'm not necessarily the soul of tact now. Back then, I said my mind and I meant what I said, and I always could back it up. So I told them it will never work because, and I rattled off why. And they didn't take kindly to that. So I wrote C2 and stomped the old code gen. So they went and did C1 with promises to upper management that it was going to take over C2 any day now. And I looked at that and said, it's a nice, good code point. I've been there. I know what it'll go to. It'll hit 30% of C2 and not get above that. And that's pretty much where it stuck. 50% on risk machines like Sun, 30% on x86, below C2. And there were some bitter feelings I got from the other side. Now, I didn't care. Emotionally, nothing hit me. But I got bitter feedback from that set of guys for a long time. They were not happy at how that panned out. And I very much got the feeling of, we are going to disprove you and do it this way, and we are going to win feeling when Graal came around. This is going to beat it. And I was like, yeah, Graal, that's a great. Graph rewriting rules, perfect. New up, perfect. It's about time, perfect. Go for it, right? But the vibe I was getting was, we were going to and get it and beat your ass. So that's my color.
There's some of that. I remember, anecdote, in early 2001, I wrote a note to our mutual manager saying, you can improve C1 to make it like C2, but then you'll have to rewrite it completely and it'll be just like C2 and just as complicated. People always have this attitude, somehow the implementation language will reduce the complexity of the problem you're trying to solve. And that's simply not true. You hear it all the time, but it's kind of crazy. Anyway, the second thing Graal has is partial escape analysis.
Yeah.
So, and/or flow sensitive escape analysis.
Which I know C2 is working on.
Yeah.
I want to say, it's a crazy Russian guy, and I don't have his name off the top of my head. You probably know him. He's a C2 lead.
Yeah, I don't remember.
It's V, not Victor.
Is it Vladimir Kozlov?
I'd say the name again.
Vladimir Kozlov. Yeah.
Vladimir.
Yes. I've seen comments from him saying that there was like in progress here on this stuff. I don't know. My understanding was they were hard at work on this because it was obviously doing something good.
Yeah, it's really a combination of better inlining and partial escape analysis, because you need much better inlining, deeper inlining.
Yeah, when I did C2 in the beginning, why were we not able to inline? For whatever reason, we started out inlining in the bytecodes prior to the optimizers. Obviously the wrong way to go.
Yeah.
And I don't know why I lived with that. I probably had too many other things on my plate. And other people could do inlining pre the optimizer. And so I let it go and just ate more inlining calls.
So there is a later inlining facility in C2. I don't know.
Right. Now, back when I did it, wasn't.
Yeah.
Yeah, and what I'm doing with AA, I inline in the optimizer using optimizer smarts and all that kind of stuff. That's all straight up.
The thing that bothers me is, tiered compilation is, among other things, supposed to open up scope for more optimization in C2. Nobody's really taken advantage of that, so it'll be interesting to see.
Yeah, don't know.
Just to add data point here. So based on our measurements, CE, the community version of Graal, it's not that impressive compared to OpenJDK. But I think it is intentionally dumbed down because the enterprise version, it shows, I would say it's better on broad set of benchmarks. And we consider this as a solid competitor to Falcon. And that's what we compare with. And so they have some stuff in the proprietary and closed source version, and they intentionally dumb down the one which is freely available because they want to make a product. But our concern is not that their performance is not good enough. They show good performance. To us, it looks like there are the ways they achieve good performance sometimes is questionable. There are some. It looks like they are cutting corners sometimes. Things like constant folding for switches on enums instead of having sometimes they do things like, okay, we know that this method generated or field generated by Java C will be named this way. Would unconditionally trust this name and would constant fold through this. Things of this nature.
Name?
Yeah.
Wow, but that's easy. I mean, but that's easy to stop that. Just if you know the name, go write a piece of code where optimizations based on the name was incorrect. I got hammered this way pre-Java from Intel compilers. It was Motorola and Intel doing benchmarking on processors of that era, PowerPC. And Intel was cheating on benchmarks, and we caught them at it. And then produced a counterexample that caused the compiler to screw up.
Yeah, other things we found, for example, they didn't, the thing was identity of boxed objects. I can arrange the code in the way where they mess things up. And for example, where in the original program, you are supposed to get the cached value, well, suddenly you have a newly allocated value with different identity.
I think C2 does field trusting as well for a set of fields, at least when constant folding, but maybe it just doesn't constant fold as aggressively, I'm not sure.
You can field trust if you declare the fields in your trusted computing base. That I'm totally okay with. You can field trust if you, for instance, pattern match the exact bytecode sequence and declare a deeper analysis that you're hand doing from a set of bytecodes, which everyone does all the time. That's perfectly normal.
Yeah, the example with fields, it is specifically to switches on enums. Java-C generates this indirect dispatch through intermediate array, and this array is known to be stable and the content is not modified. But they just look at the name of the field and say, well, we know this, we know what this array is, and they
the values field for enums.
Yeah.
I would claim that if you pattern match the enum class on the value references, that's a legit transform. That is, your trusted computing base. One more very late arrival. Your trusted computing base can include things like, that there's a value field of an array. It contains the enums in order, and it's write once and then never touched. Okay. You validate the write once bytecodes by bytecode pattern matching. You validate its write once by just observing that there's no readers in the bytecode.
Oh yeah, this is how you can do this like in a right way, but not just by matching the field name and assuming, well, nobody will ever modify it.
Well, right, but you start by matching the field name and say, I have an enum, it has a field name.value. It's the values array. Now what can I do? Okay, let me run this Oracle to go validate that this values array is being treated the right way. Okay, the Oracle says yes. Boom, good to go. Now the value array is known to be constant, pre-compiled, pre-filled in, just in order the enums, and I can switch optimize through the values array. It's all great. I think that's legit. All you need is an Oracle call somewhere.
Yeah, this can be done. This kind of like all these things which we found, they can be fixed. It's just when we find it here and there, when we find this kind of shortcuts, that raises a question. Well, how stable and thorough this thing is. And
no, I would claim that those kind of shortcuts are the most stable. If they've got their Oracle done correctly, they're really simple. I added some new information that is sort of trivially, locally, obviously correct, and I can immediately do a next round optimization of, I don't have to fetch the value, the index into the value array is in fact the index into the switch.
But no, my point is that currently, Graal's implementation only looks at the name of the field and doesn't do any analysis to prove that this property holds.
Okay, right. And what I'm saying is that to verify that Graal doesn't do the Oracle, that cheats really, you have to go make sure there is nowhere on the code path prior where he does the Oracle and then just allows or disallows further down the line. If he doesn't do the Oracle, then he's wrong. And that you should bust his ass by producing a broken class file that you just write some bytecodes and declare it a jar and hand it to him, and he'll do the wrong thing and break security. Say, giant security hole because you cheated. Okay, then they have to go write the Oracle. The Oracle's not that hard to write, but they have to have it.
Yeah, that's why I'm saying this can be done. It's just, we need to extend, they need to extend the analysis.
If you start losing sales because of this kind of a nonsense, you should take them to task on it, make them do the right thing. And then you should do the Oracle yourself, right? Go implement the right transformation using the keyword. The reason they stuck that in because it optimized some code, right? And people doing enum switches, that's gonna happen and it can be hot. So wouldn't it be nice to go optimize? Okay, you need to lift value into your trusted computing base. How do you do that? Well, you write this Oracle that does the right test. The Oracle's, like I said, Oracle's not hard to write. It's a dumbass pattern matcher with the bytecodes. Walk all bytecodes, ask the question, is there a store of the value? Did it escape out of a method illegally? Okay, then I don't know. No stores, it didn't escape, boom, done.
Or you use a type system that supports immutability.
We're stuck with bytecodes. The barn door has closed and the horse has been running and populating itself in the wild. Yes, it would be nice if. Same with final field, Cameron. You would have thought that final field would have been, you know, sort of the right answer if it had extended to arrays. No, no. People reflected their way around finals all the time. I tried to do final field optimizations at Azul, and immediately 3 of the largest frameworks, Spring and 2 other well-known frameworks, cheated on final fields and broke. So
we actually do it right now. We do it with speculation that nobody ever does that, and then we intercept this kind of modifications.
Yeah, but then you don't need a final field. You instead have observation that you have a field that has been written a long time ago and has not been written yet again. That's
exactly. And we do it for non-final fields as well.
Mm-hmm.
So we can optimize effectively finals.
Effectively final. Yes, that is the correct answer. Bam, bam, bam. At stable, right? But you can't trust at stable because it's a cheating bastard. Because I just wrote at stable everywhere, so the compiler would cheat on me, and then I could break security. So you have to have the compiler do the right thing. And actually, for stable fields, the right thing involves the runtime because the interpreter can update the field. Probably, actually, you can have unsafe update fields, and you have to decide. But if I pull out unsafe on myself, I guess I blow my head off anyhow. So done, fine. Wow.
That seems like the tricky thing, though. Actually verifying that nobody writes this stuff. So an Oracle would have, I guess, some kind of trapping in unsafe or reflection that would invalidate the optimization.
To do stable fields, you have to hook. Oh, I saw your background for a second, Mark. Nice light wooden floors. Good. See, same with
oh, you saw the real background.
Yeah, the real background. Yeah.
Yeah, it's not a bad room.
So, I was on a roll. Oh, no, so I'm rolling through the places where you hook, because I've done this before. You hook the interpreter right by having the interpreter check that you have a field has the property that a compiler has declared it as a not modified field. And then he has to stop and deopt and go again. The C1 JIT, the C2 JIT have to emit a, if there was a write, I cut off and go to the interpreter. That's probably it. You just hook a couple places. Now to analyze that it's right rarely, you need to have a profile counter that says the last time this thing got written. And then to be stable, the JITs probably don't want to emit counters, so they just want to say, if I suspect this guy is going to be not written, I'm going to not generate code here, I'm going to cut off. And then I'll go to the interpreter. If you do hit the path that I JITted to write code, and the interpreter will bump the code, if field got written and deopt everybody and take care of business. It's not too many places you have to hook, but you hook things outside of the compiler. So this is not a compiler only hack transformation. Does that answer? Somebody had the question.
Yeah, I guess I'm still, how, like if you don't know the offset that's being accessed, how you would.
Well, you do. You have a field.
Yeah, but let's say you're using unsafe with a non-constant field offset.
No, I claim the right answer here is to give it up on unsafe.
Oh, okay. But yeah, okay. That will make things tricky because a lot of JDK APIs now use unsafe under the hood to do their accesses. So
if you use unsafe to write to a field that has been declared final, I claim you're clearly blowing your brains out. But if you use unsafe to write to a field in general, I'm willing to argue that that's not a legit hack. I'm using unsafe to do, which maybe it's fair, maybe, I don't know. What do you want to declare unsafe to be? What are the semantics? Unsafe bullshit. Unsafe. What are the semantics? Do they preserve Java happens before relationships on field read and writes? What if I write unsafely to a volatile field? Do I get happens before relationship or not?
yeah, I think it inserts barriers in that case.
Right now, unsafe does I look at you and decide I know what your base is. And if you have a constant offset, I declare I understand the field. And he basically lifts you to a Java field if he has a compile time constant offset and base. That's what I remember C2 doing somewhere in the depths of time.
Yeah, so you basically say if the offset is not a constant, this is basically an unsupported use case, so we don't do any checking. Okay, makes sense.
Right,
yeah.
right.
But to give an example, VarHandle uses unsafe underneath to do object field access.
Okay.
So that
Yeah,
that would work.
you know, if the VarHandle semantics enforce that the field is known, then the one unsafe load or store memory op will have a constant offset, and that will get lifted by the compiler. If it's a random, I took a random variable offset field and I did an update with some other value, yeah, I claim all bets are off. And what the hell are you doing? I don't know. I thought VarHandles was stupid, so that's my take on that one. You're going to shoot yourself in the foot. You're going to deny classic good optimization because you have a stupid API. I don't know. People do. It's not what I would have said.
So I think I missed an interesting point there. So are VarHandles noticeably less efficient than unsafe?
Well, they have a ton of overhead it's supposed to optimize away. If it optimizes away, then it's an unsafe. That's what I just heard.
Yeah.
So I thought there was, Shiplev had an article on this where, what's the precursor to VarHandles, the atomic field updaters were optimized to the point that there was basically no overhead. So I assume VarHandles would have that as well.
Atomic field updaters had the property that you had a constant, you had a known field. You had a constant offset, which is exactly the case I'm talking about. If you know the base type, you're using unsafe, but you know the base class and you know the field name, field offset, you lift it. C2 lifts it, declares it. It's actually just a field reference done a funny way.
Okay. But with VarHandles, that's not possible.
And if you handed a random field that I don't know what it is, and he does a lookup and comes up with a strange ass field with some funny unknown compile time offset, yeah, I claim all bets are off. And I think that should be the right semantics. And of course, unsafe makes no guarantees. It's just like, which turns out means VarHandles make no guarantees. What the hell you use VarHandles for? You get all the same guarantees that you get if it's unsafe.
Well, I didn't say VarHandles don't make those guarantees. I think they do. I'm just wondering if there might be cases in the JDK that use non-constant field offsets in that way. But VarHandles, underneath they use lambda forms, which then gets rendered to bytecode. So you basically get a copy for every kind of access you want to do in the most optimized case. So then everything should be constant again and it gets lifted.
Then you should have the right answer. Yeah, it should still work. Yeah. It's same as, not same. It's some, well, no, okay. I mentioned the interpreter have to hook it for the stable field update. You have to hook reflection as well. But if you unsafe lifts, then you're good there. What happens if you run it through the interpreter? The VarHandles are only interpreted. What does he actually bottom out as? He doesn't do unsafe in the interpreter.
Yeah, it should. There's a lambda form interpreter as well. It's basically, it just interprets the lambda form. Basically, it's a little IR, and then it calls unsafe. Like I think there's some pre-generated.
He's actually calling the interpreter's calling the Java code unsafe, which is all intrinsic. So he has to jump to some Java intrinsic. Which he could do it there. So yeah, so then the unsafe basically do reflection on the base. I look at the base class. Is it in the heap? Okay. Is it a Java object? Okay, it's a Java object. Now I can do an offset. I got the field. Expensive as all hell, but it gets the Java field. And then you can do a stable field optimization there too.
Yeah. I guess because technically they're not really field offsets, they're field cookies, but they just end up being offsets. So you could encode some more information maybe in the high order bits of this field is final. So you need to go and do a deopt.
Stable. Let's call stable. Final is the Java keyword that is useless because people override it in reflection. Stable is a better word. This field is stable. Yeah. But you don't know that at the time. You have to go ask. The cookie doesn't know that. The generator of the cookie doesn't know that.
Yeah, I'm thinking about the case where you have something that is more or less statically declared as trusted, maybe with an annotation or.
Yeah, if it were right, if final were language enforced, that is, you didn't get to cheat on reflection, then final would have been the thing. But it didn't work.
Well, even if you could enforce it, but then detect when you actually reflect, that should be.
Right. So if reflection threw an error, you have enforcement. If reflection does not throw an error, you have detection. What you have right now is detection. but you don't detect everywhere, which is what, Arthur was saying, we do this thing where we detect everywhere, and you can go do the detect everywhere and declare it stable. And now you can use it like it's a final field, do the right optimizations based on it. Well, and then you can be very like coarse, granular in terms of how you deopt. Like you don't have to detect specifically that this field was modified. If you see that, well, it may be modified, yeah, you would deopt things which you think might be modified. And there is this like design space where you choose to put the As long as your deopt path is not taken very often, you don't fucking care why you deopted, because you're not.
Yeah. There's trade-off. Yeah, how much you would deopt and how much overhead you would put on the on individual access in order to intercept.
Right. Yeah. I still think you have to hit all the places I mentioned. I'm trying to think if there's a real shortcut. If you have a class, if you have a golden instance, there's a cheaty thing that just says I need to find it if you got another new happens. And then there's I have a class that anyone has a store field floating around. And if there's no store fields in the base class, I'm also done.
Also for, I think for effectively final, we only do this for private fields. And this limits the scope we need to analyze the bytecode.
Well, fine. You're just doing a scope limit thing.
Yeah.
Because I would have said, if you hook it in the runtime, you don't care if it's private or public or whatever. The runtime tells you somebody touched it. But then you have to hook everywhere in the runtime.
Yeah, exactly.
If you put it in private, you still have reflection, right? You still have to hook reflection.
Yeah, correct.
Okay, fine.
So what are you actually analyzing? Because if the field is private final, I guess there would be, well, you would expect there not to be any stores in plain bytecode, right?
So first, when I say effectively final, it is for fields they don't necessarily mark as final. They are just.
Sorry. You're right.
And then when we load a class, we see so we select fields which are only stored in the constructor. And in this case, we can apply the optimization.
Because there's another theory that says we profile all field rights, all of them, in the interpreter, and maybe in first tier profiling compiler, by just counting field rights on a class. And the count goes 0, 1, 1,000, and then infinity, or whatever you want to cut off at. And then you go look when the JIT time comes. And if it's a write 0 or write 1 field, you go ahead and try the optimization. Try it, independent of whether it's private or public, independent if it's final or not final. You just profile field updates. And I never went there, but that would seem like the obvious thing to go.
Wait, what if you have a store into this field and the code which does the store is compiled in the final tier, which does not have profiling?
Right.
How would you trigger deopt when this code modifies the field?
Oh, because the compiler just stops and deopts. I have never written to this field ever before. The path that leads to writing this field has to be extremely rare, and profiling should totally say that, or I would have found the path to the field right already. It's never been taken before. Go to the field have been updated. Okay, fine. So you just,
okay.
It's a low path, it's a low frequency path. Cut it off.
So the store in final tier compilation would have an uncommon trap, but you would also need to deopt everybody who assumes that the value is stable, and this would probably be done in the interpreter after you deopt.
Yes, as soon as you deopt, you go deal with all the issues that come from that. Right. The same as anything else. If I have a path that has a new class I've never been loaded before, I clearly have never taken that path where the class has been loaded. So I deopt. Okay, after the deopt, somebody has to come along and blow everyone else out who's using who assumes this class will not load. And also, you have to load the class. So first you come through and you blow down everybody who has a compilation. So this was something you guys are, I don't know if you guys are using the same. I did a bunch of work on the dependency information for the C2, C1 compiler thing. So ways in which you detect, where you record who was modified, or who depended on what facts. So that when the runtime detected a fact change, he could walk the list sort of efficiently and discover all the methods that had to get blown down. And
a couple of years ago, we actually backported OpenJDK implementation of that.
Okay, fine. I had a version which I claimed had a lot of, the hard part obviously is you have to keep backporting with OpenJDK. The good part was it had a lot of useful properties. In particular, the data was all stored in the heap, the Java heap, so I didn't have to deal with lifetime management and a bunch of other things going on there.
Yeah, we did that because we needed to, I think we needed to introduce new kind of dependencies, maybe even for effectively finals. And that was tricky with the existing implementation. And
okay. I was adding new dependencies. So why I did that is I was adding new dependencies. It was a hell of a lot easier. It was fine. The other thing I did was I did a lot of profiling of dependency data itself directly, and did some structure changing to densify the dependency info, which had gotten big and fluffy and complicated from Sun, but it's fine. It's a long time ago, water under the bridge.
Yeah, there's also benefit for us to stay less divergent from OpenJDK.
Yeah. No, I totally get it. I totally
when
get
the code evolves there, it's easier for us to pick up changes when it's not different.
That was one of my big hacks I did in the first few months walking out of Sun. Was like, God, I'm going to fix a bunch of issues. One of them was dependency info was screwed up, difficult, risky, not risky, flaky, fragile. Fragile is the right word. It was very fragile. And I
think over time, I think just more effort was spent on these parts of the runtime in OpenJDK than at Azul. So when we look at things now, it's often not too bad to backport what they have.
Yeah, makes sense. Dun, dun, dun. Yeah, inlining in C2. Sorry, just reading through chat. And Fathark, nothing to do with fucking hard. Purely functionally, what the heck? Name is fine. Okay. And uniqueness types. Okay, I'll stare at that one too. Okay. Anyone else?
Actually, I have a question to throw out to the group. Haven't been able to find the answer anywhere, and it seems like there's a chance that someone on this call might know. I've been working on a system that detects when a thread is blocked. I'm kind of doing a poor man's version of Project Loom. And so knowing that the thread is blocked lets me spin up another thread to compensate for it. And I wrote a Java agent that took care of almost everything. Like I instrumented lock support, so I know whenever a thread parks, and did all file IO, like all that. But the one thing I couldn't do was know when a thread blocks trying to acquire a monitor, right? Blocks trying to lock it. And I'm wondering if anyone had any hints as how you might, in a clean or dirty way, get at that information. Right now, I have a very dirty post deadlock detection thing, which kind of sucks. So if anyone has any pointers,
I hooked the runtime directly back in the day. The locking limitation had to get redone at Azul, and it was done at Sun, and that was the JITs all jitted out locking limitation and deopt around the locks and crap like that. So we knew exactly what.
I imagine all that locking stuff is down in the truly native layer as well.
No, most of it's emitted code. So at Azul, the cleanup was millicode, which was user mode assembly code that would do machine code that you're trying to get done. But yeah, you're actually talking you're even talking on the runtime. No, we call back into the runtime. We call in the runtime saying we blocked on the lock. Millicode has declared that we can't take this lock. We request a blocking operation. There was a VM runtime support for this compiler. There's a lock support for the compiler that said this thread can't take a lock. I'm going to block it. So he grabbed an OS monitor and did whatever the OS does for blocking a thread. And prior to that, he did all the usual shit that you would expect to do for announcing you're blocking a thread. He had to do shit with wait lists and who to notify next. And I don't know, there's a bunch of random things floating around depending on your
Any idea if that's something that a user can get a hold of?
Are you rebuilding the JVM or not?
No.
And then
So Java agent is probably as low. I guess I could possibly go down to JNI, but I'd rather not.
Go ask the question. Of the source code. Go to the source code and find where the callback into the VM happens from hitting a blocking code. There has to have the word lock in it somewhere as a VM entry point. It's probably called VM entry. I want to say it's a VM entry from native, not even from native, from Java code. It's not a native entry point. It's because you're still in Java code, because the Millie code will just do like spin locks, do cases and spins, and then give it up, right? And he says, I quit now. Right.
Yeah, it's the I quit part that I'd be interested in.
Right. So you're still in Java code and you've called into the VM. So it's a VM entry from Java code, and then with the name lock, and he clearly is going to do a monitor, enter, monitor, exit. He's going to do something with OS level locking. That goes to probably the OS shared code, which will have a locking implementation based on your OS. But somewhere in there, if anyone has ever put a hook in for user mode things, that would be where you'd find it.
Okay.
But I don't.
Time to read some JVM code.
Yeah, I don't have it off the top of my head.
It sounds like something that could be a JFR event as well, or something that could be added as a JFR event. Seems interesting.
Oh yeah, totally.
Right. Yeah. Presumably the profilers are able to get this information.
Yeah. And profilers are able to get it. So you should get it as soon as a profiler gets it.
What information?
Right. That maybe.
What information would you need, and what thread would you want that event to show up on?
Ideally, I would want it on the thread that is about to block.
Right.
That's scary.
That thread is now running some bonus extra code. Oh, but you're going to run bonus extra Java code on the failure to lock.
Yep.
Right. He wants
right.
To,
so like right now, like
natural, he wants to inject Java code in between the fast lock and the slow lock.
Yeah, I'm like I said, I'm doing it right now for Park. Right. So like all of Java util concurrent, like if it goes to Park, I get to step in for a few nanoseconds in between and take an action. So. It may not be the best idea long term.
Blocking action.
So far, it's working.
If you ever take a blocking action,
that?
if you ever take a blocking action, in particular, if you ever do any allocation which blocks for GC, you are dead.
The first thing I do when I go in there is mark a bit so that if I re-enter, I ignore it.
I'm still thinking you're toast on any blocking action. Re-entrance is obviously an issue. I don't.
Well, the re-entrance through taking a blocking action. So I've these like blocking interceptors I've verified like yes, I can block inside the blocking interceptor and it doesn't stack overflow, for instance, because I turned it off from my thread as soon as I intercept.
Amongst other fail modes, including people who know damn well in their heart of hearts that thou aren't blocking because you're between fast lock and slow lock. And therefore there's no blocking operations in there. And that's heavily asserted for in the JVM because there were a lot of bugs involving that turned into deadlock, right? The main issue is that you haven't yet released the JVM lock, but you think you have because you failed a fast lock. So somebody comes along and does something and they block on some low-level C thing like allocation or stack regard, unguard page because you're at the edge of Stack Overflow, whatever the hell. But you have not released the JVM lock, so you can't do a GC. Then a GC comes along and he says, give me the thread lock, which never happens because you didn't unlock it because you're still in the middle of fast lock, slow lock. And now, like, it freezes up and right, no GC and everyone's dead. It's all toast. This is you be walking dangerous ground. Like unsafe, I understand the risks. This one is, I understand the risks are fragile, delicate, and not easy to spot. Whereas if you flipped a bit somewhere and did a notify on another thread, you're probably better off. And the other thread wakes up and says, oh, somebody went to sleep on me on a block. I better do what I'm going to do. But it's a different thread. And the handoff via a notify call and an unsafe bit goes through all the standard VM handshakes, and no one gets their tidy whities in a knot.
Right, as it is, what I do is basically start another thread. Actually, that's not even true. Actually, what I do is pretty close to what you said. When I'm notified that my thread's blocking, I schedule a task in another thread that says, if I haven't unblocked in some short period of time, then please spin up somebody to take my place, right? So
now, when you schedule a thread, how do you schedule it?
So I have a thread that is running basically like a timer task, right? So I'm scheduling a timer task for that thread, like, hey, if I haven't canceled this task in 10 milliseconds, then please run this task in your thread, right? Like my thread's done. The only thing that the thread that's going to block does is insert something into a concurrent queue that says, in 10 milliseconds, run this.
What is the thread that's going to block doing in between the fast and slow lock? What you just said is I'm inserting into a concurrent queue. If that
so that's the code I'm going to inject.
If that insertion does an allocation, which it almost surely does, I claim you're walking a fine line. You'll run until a GC cycle hits right there, and then you will die. That you'd be better off no allocation, which kind of limits you, so you flip a bit. Now, if your other thread is doing timing on its own independently and doesn't need to wake up every 10 millis, he wakes up and looks for this bit. Then that's the only handshake you need is you flip a bit. And the other guy wakes up, sees the bit, and he doesn't wake up because you block, but he wakes up within 10 millis or whatever your timer is. He runs, tests the bit, and go back to sleep until the bit's set, and then he does the right thing.
Right. So, but it's specifically well, I understand there's a lot of things that could be worrisome here, but its allocation was the one that you're definitely thinking is a problem.
No. Well, yes and no. What I'm thinking is any blocking operation, of which allocation is the most insidious, because allocation will only block if your local thread is out of stuff and you need to do a GC cycle because your local TLab is full. So it rarely ever blocks. But when it blocks, now you're in a funny zone. Now you're in trouble land. Whereas a much more commonly blocking thing that you accidentally did, like you took a concurrent queue that wasn't concurrent, but it was a blocking queue, and you blocked, now you have nested locks, and now life's sick. More readily, apparently. But like you can't do a proper stack crawl on your own thread while you're in between the state. So you can't have any blocking operation, including failing to take another Java lock. Like concurrent hash map will take a lock on a write. He stripes locks. It's unlikely you conflict, but he can. If he takes a lock on a write and you're in between the fast and slow, your stack will not be crawlable. So I claim you should do nothing that can block, which limits you to shit like flip a bit.
Okay. Yeah, and there you're specifically talking about in the realm of I'm trying to get in the place of object monitors, but not the park stuff I've already done. That's a less risky path.
If you've post parked, then you've already.
Well, this is on your way to park, right? A thread saying I want to park, and I'm saying okay, but right before you park, I'm going to run something.
Right. So the other version to hook, and see, so I don't know how if you can. The other hook is you hook it after you've given up your Java stack. You give up the stack lock. Right, you know, the stacks are locked in Java, right? You're not allowed to modify your own stack because GC will do it, or you are modifying your stack and GC is not allowed. So there's a stack lock. You release your stack lock, then you're good to go. You can block. But is there a place between when you release your stack lock and a user observable interceptable spot between when you release your stack lock and when you call the OS to do an official OS level block? I don't know if that place exists. If that place exists, you know, boom, done. Do whatever the hell you want. If that place does not exist, I would never, ever, ever take a locking operation.
Okay. Maybe I'll stick with my current untie the deadlock later with slow, dirty approach.
Yeah, whatever. I mean, if you're doing large scale concurrent throughput where you lose a thread, so you need to wake up a replacement. I've done this totally at H2O all the time. I'm looking for batch efficiency. If it takes a little while to detect I've lost a thread, it does.
Yeah.
If you're doing low latency trader things where you count nanoseconds to blocking and unblocking, you know, you gotta do something different.
No, yeah, I'm more in the I can.
Yeah. Okay.
It can take a little while. It was just like if I could just take care of this one thing, then I wouldn't have to.
Right. Yeah, I get it. Yeah, fine. Well, you know, throwing down a bit's not a hard operation, and it's not conceptually hard. Your background thread that's going to rescue you anyhow just wakes up once every 10 millis, runs for a fraction, goes back to bed. Right. And you just test these bits, and the threads, when they go to sleep, throw the bit, they go to sleep.
Yeah. If I can figure out where to
Well, if you're
where
going to
to
hook
flip
it,
that bit. Yeah.
if you're going to hook
Yeah,
it at all,
once I find the hook. Yeah.
yeah, if you're going to hook it at all and you found a hook that's in the wrong place, I'd say only do bit flips. If you find the hook after somebody's released all the locks because it's a JMX bean callback, or I don't know what the fuck people have done for flight recorders, you had to have done something, then, you know.
You're saying released all the locks, but I'm talking about in the case where you're blocked trying to acquire the lock. So there wouldn't be any locks released in that case.
Always when you're talking about JVM implementations and locks, you must distinguish between the VM notion of a lock and the Java notion of a lock. The Java notion of a lock is built from the VM notion of a lock. The VM notion of a lock has multiple pieces parts, and some of them also use the word lock because.
Okay, I see what you're saying. Yeah.
Yes.
Gotcha.
So I'm saying there's a fast lock. So Cameron had the right term. I forgot about this term. Fast lock. There's a fast lock effort. At that time, you still own the Java thread owns the Java thread stack, and GC is not allowed. Okay. When that fails, he calls back into C code. He still owns the Java thread, but he's put cookies on the stack, so the stack could be crawled in theory, except he's allowed to modify his own stack yet. Now, at some point, he releases his stack lock, and then at some point, he calls the OS locking behavior. He calls pthreads, pthread lock, or whatever the fuck it is. Right, okay. In that sequence of events, you're okay to recall Java after you've released your Java lock, and the JVM bytecodes know that you're at the bytecode lock, but you're post the stack release of failing a lock. So the Java 1 bytecode has stages that you can't represent in bytecodes. And there's, I'm pre the lock, and I am release the lock, but not executed any bytecodes afterwards. And then I had to reacquire the lock, and then I can run bytecodes afterwards. So you're in between the slice of the Java bytecode that says, I've released the stack for the JVM. I can now actually take this thread and just have it run some other code by reacquiring the stack lock, reacquiring everybody. But if I deopt, I'm going to come back to this bytecode. And so if I throw everything away on my stack and come back here, and then I reacquire the lock and carry on, I'm probably okay. So there has to be a zone here where you're basically treating a Java lock bytecode as a function call to arbitrary Java code. So, right, and so this is where I claim if you ever do a stack crawl, I'm not certain the system will ever recover. The obvious stack crawl is you blocked and then the GC crawled you. But the other one, I guess, would have been you deopted, which tries to redo in the interpreter. And if he ever crawls out of the interpreter head, then you're probably dead as well. If you only do things like I call in the interpreter and I do no blocking code, I just set a bit and then I return, I think you're probably safe. Although the interpreter will allow a GC cycle at every point. Yeah, I don't know. This is still tricky business. And if you obviously if you take a native call, then it's all good. This native call does like we were talking about the other time, the specialized native or whatever they call it, the super nice native, critical native. You call it critical native code. I'm in the middle of a lock, critical native.
Right.
I take no lock, but I take some handles to Java objects. I flip a bit, and then I get out with my critical, and no one cares because it was fast and quick and didn't block. But yeah, if you're in a bytecode and you want to crawl a stack, the stack crawler will say, you're not in a function call, you're in a lock bytecode. So there's something weird going on here. And I don't promise survivability in that zone. So don't crawl your stack while you're in between.
Right. Well, I'm a little bit more scared than I was before, but that's probably a good thing.
You know, but, the other one is it just works and only crashes every now and then, and I don't care.
Right. Yeah.
Cool. I was wondering, what kind of information are you looking for from this tool? Like what kind of output?
Well, I'm literally just looking to know that the calling thread is entering a blocking state, right? Like.
Why don't you describe the use case, Mark, in terms of because this is for a giant ass application that locks up all the time, right?
Well, it's for a huge application that doesn't make particularly good use of all of its CPU resources, right? So the simplest way, I've been building something, like I said, it basically looks like Project Loom, but in Java 8. And so I have a thread pool, like one thread pool for the entire JVM, and then like these like proxy thread pools that look like thread pools, but they don't have any threads that feed into the main pool. And I'm trying to dynamically resize the main pool to make use of the actual cores, but like I'll add more threads to the main pool when one of the ones that's already there is blocked. It's like, okay, we're not using a core, let's spin up another thread. So I need to, like, when do I spin up a thread? I need to know when other threads block. Like I said, I've got coverage for everywhere other than when you block on a monitor, which I thought, oh, like that, how often do like so many things block on a monitor, on the same monitor, that this will be an issue. And then Log4j came in and all threads blocked on Log4j's. Like,
yeah,
monitor.
so H2O, I did this giant distributed parallel computing engine with infinite counts of things that you might think would block and lock in cluster-wide operations. We had to solve all this. And a couple of things, like I specifically repeatedly killed Log4j. A bunch of people, oh, Log4j, no. Log4j, no. Log4j, no. No Log4j. Okay, independently of no Log4j. We did all kinds of shit we had to do. But everywhere where a thread would block, I had a user mode, I had application mode callbacks I demanded as a coding style. So I got
that's where I started, and then I got to the point where like, okay, let's start putting in those user mode calls. And I looked at the code base, and I'm like, there's too many places to actually go and do it. So it's like, oh, we'll have a Java agent that takes care of the dozen or so base places that everything will funnel to anyway, right? Like, okay, now we don't have to go and modify,
so the reason I did
a million lines of code.
User mode locks is that I could do lock ranking. So it wasn't user annotation locks, callbacks, but it was lock ranking. And the lock ranking gave me the guarantees that if I didn't change ranks, I didn't have to do anything. But if I changed ranks, I must spin a thread.
So what is lock ranking?
Lock ranking is you only acquire locks in rank order. If you don't acquire them in rank order, then you suffer deadlock. Okay, so there's an order,
gotcha,
and out of order, and the way around the deadlock is you spin up another thread. So some of them I said, thou shalt be rank ordered properly, and then this isn't a problem. And some of them said, yeah, we can solve this by throwing out another thread. But everyone had to be able to make forward progress. So somebody was making forward progress. And the obvious one where you fail, where adding a thread succeeds, is someone is blocking, waiting for a result that they couldn't compute themselves, that was stuck on a work queue waiting for a spare thread to go compute. And mostly here I used Doug Lee's fork join framework and declared that if I needed a piece of work and it was stuck on a work list, I could go compute it. And so a thread needing the next piece of work just went to the work list for the piece of work that he needed to make forward progress. There's a different coding style there. So this is a combination of lock ranking, thread pools at different lock rank levels, so that I would have a thread pool of size X for lock rank, whatever, that was enough to get forward progress. Sometimes the thread pools were as big as the cluster. Sometimes the thread pools were as big as your CPU count. Didn't matter. It depends on which thread pool, which lock rank you're dealing with. But once you guarantee forward progress, that level of rank would clear out. And then the thread who was one rank below would get his result, wake up, be able to run, make forward progress. And then the higher level ranks would time out their extra threads and toss them away. So rarely they would need to spin up a few threads to break the deadlock, and then they would go away. So I didn't have to have bazillions of bonus threads all the time, but I had to have some amount of threads at every lock rank, usually having to do with IO. You had to honor somebody else's request. You're on this cluster, and you need something from that guy, so you send him a request and you block waiting for a request from that cluster. So that cluster has to honor your request at a higher priority as his own internal requests, except transitively across the cluster. So there's a rank that goes depth of cluster in the worst case scenario that you had to honor, or else you block. And then if you went in a cycle and you came back around and you needed from here and you got from here, but you went a cycle, then you were deadlocked, and that was actually a bug, and you failed your lock ranking. And the lock ranking prevents that bug. So I had an assert that would pop up and said, okay, the code's ill-structured, you have lock ranking bugs, fix your lock rank first. Okay, now that it's not cyclically deadlocking directly, like no amount of extra threads save you from the deadlock there. Once it's not cyclic, then it ranks up, and then everyone's at a different thread pool. The thread pools locally are big enough to make progress. You get a guaranteed forward progress, and then you're done with deadlocks. And in fact, everyone's making forward progress sort of best effort anyhow at that point too. So we went through this a lot. H2O was usually, one cluster for a lot of folks, but small cluster 4 to 100 node clusters. But we would be spawning events at the millions a second to billions a second event rate, of which cross node clusters on a big cluster would be millions to billions across clusters in a data center. We'd hammer the hell out of the thing. And that prevented all manners of deadlocks and stack overflows and rock ranking, blah, 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 whatever. It all worked well in the end. But it took me a while to sort out that, I can actually get deadlock around the cluster in a corner, and I actually have a lock rank. And I had to do lock ranking right because I did it manually for a while, and then I had too many bugs. And so I started putting asserts in and found kind of funny corner cases where I didn't expect. And we had retry and IO bugs or IO errors had to be retried at various layers that caused all kinds of extra locks. So there's a lot of lock ranking that's on unexpected paths. But once you got it nailed, it was nailed. And H2O would every time slam all cores, all CPUs for whatever the hell you're doing until the job was done. It was brutal and fast. So there's a way to do it. I claim ponder lock ranking as one of the ways to at least catch deadlock way the hell more deterministically than accidentally I found a deadlock. And then if you have issues with the deadlock is somebody on a work list and the work list is starved, then you have a different, you need to spawn threads. And you can get stuck in a loop where you spawn infinite threads because every thread wakes up until you reverse the work list in the wrong order and launch a thread for every cork queue that dies. We totally went down this path too. And the lock ranking fixed that as well by forcing the ability to get forward progress at a particular rank level every time. And the only way you had to spawn beyond CPU count for efficiency was if you went up a rank. So
okay,
I like how
we'll definitely have to read up on lock ranking.
Yeah, this concept is really, really simple. It's just I can't take if I own some set of locks, I have a rank. I cannot grab a lock of lower rank than the current rank I hold because that risks deadlock. I can only grab a higher rank lock. And you can flip up or down. Yeah.
Does that actually does that approach have to flow out to the architecture of the application? Like the code using H2O had to be aware of lock ranking and declare it, or was it just something you were able to do internally?
In our case, it was usually, done internally. But that's because the locks being acquired were internal. If the application had locks and we were trying to cluster the application, locks only worked on one node. They didn't go cluster wide. Fine. So there was usually a bug in the application. So what we really did was we said, all our applications are giant ass data parallel. And then it doesn't make sense to talk about locks. So we gave you a single threaded paradigm to code in. You wrote code that said, for I equals 1 to n, where n was trillions and zillions and didn't care, do a bulk 2D table thing. And then we auto-parallelized that. So you had bulk array operations where you wrote almost anything you wanted in inner loop, except no log for J, no locks in the inner loops of your code. But you didn't need to. Okay, my cat is trying desperately to get me to go eat lunch or pay attention or something. I don't know.
Well, cool. Thank you for that info.
Yeah, go look up lock ranking. It's not a hard thing. It might be hard to put it in a big application, but it will save you from your deadlocks and give you efficiency too. And well, I don't know. Just see how.
I suspect I ultimately won't be able to use it because of my big application, but it sounds like an interesting read.
You have it in your bag of tricks. You should definitely have it in your bag of tricks. Yeah, priority inversion. It prevents priority inversion, Zen. Exactly. Let me go look up what this says on priority inversion. Let's see if it says lock ranking here. Rank.
My question is, you keep talking about ranking. So is this same concept of priority?
Related, not the same.
Not same.
But priority inversion says I have a high rank thread. I have a high priority thread. I want it to run right away. It's blocked by a low priority thread.
Yeah, I know that.
And then the worst case scenario is the low priority thread is itself blocked because it's low priority by a mid priority. So the mid priority thinks it's beating the low priority, so it can just run forever. So it runs forever, never giving up whatever the low priority might want because it doesn't need to because it's higher priority. Whereas the high priority guy, higher than the mid priority, now can't run because he's dependent on low priority. So
yeah, I mean, what's the difference between ranking and the priority? Because when I read the source code of hotspot, one thing bugs me because it's like a terminology. So I feel that hotspot authors invent many new concepts, new terms. But
lock ranking is not a new term. This problem came around as soon as people had locks and priority threads. So Hotspot internally uses lock ranking, and there are like 50 different ranks inside of Hotspot internally. It's crazy. I think H2O has way fewer ranks. Okay. I think I gave a slot for 128, and typically 10 are used, and most of them are just +1 of something else, so you don't actually have to think about it either. Lock ranking will prevent priority inversion. Because when a high priority thread tries to grab a lock that is owned by a low priority thread, the rule will be that it's grabbing a lock out of order. It should not be able to grab that lock. But between a low and a mid and a high, somebody grabbed out of order for a priority inversion to happen. And lock ranking will throw an assert at you saying you grabbing out of order. So they're not quite the same. You can. Not quite the same. Okay. Yeah.
It sounds like ranking is like a fixed order. It's like a fixed order, but priority sounds like a more dynamic.
Yes, you decide I want this thread to run high priority wherever you want it to run high priority for.
Okay.
Ranking locks is I take all my locks in the system statically, and I give them a number, a rank, put them in an order, a tiered order.
Yeah, I see that.
And I have duplicates at some ranks all the time. I have locks per core. In a cluster, I had same rank could be one set on this node and one set on this node. They're different address spaces, different locks. Even on one guy, I might have locks per count of CPU or whatever. There might be more than one lock. Striped, however, at a rank. But the guarantee is if I own a lock at a rank, I will never grab a lower priority lock, only higher. And then the next guarantee is because of that, somebody tops out and says, I'll never grab a lock, or I'll only grab a high priority lock against other people with high priority locks. And so we'll fight through with forward progress until we release our high priority locks because no one will get deadlocked there. Then once the high priority lock is done, the next priority level down will guaranteed be able to make forward progress. So it's a guarantee of forward progress.
So is this all locks in the system have a rank assigned to them?
If they're participating.
And is there a total ordering?
There's a total.
Or
there's a total. That's
so
not quite,
two locks can't have the same rank?
There's a tiered ordering because two locks can have the same rank if they cannot be taken at the same time anyhow because you've striped the lock. Okay.
Okay. But you can never acquire two locks of the same rank.
Yeah, I think that's correct. Yeah. Okay. You must always increase rank.
Okay.
And sometimes the terminology is upside down. So I say increase.
Right. Yeah.
Stacks crawl upside down. Yeah. Fine. Yeah.
A predetermined order.
There's a predetermined. So every time I declare a new lock, I have a structure wrapping the lock that includes like the lock rank it contains, the static lock rank that I declared in the source code. Typically, if there's a pool floating around, there was something else about a count of people who are running and striped at this level, or is a thread pool associated at that rank. At H2O, I did the lock at Sun. Lock ranking was per lock declared in the VM. There was a list of lock ranks in an order, and you can go find the source code where it says VM lock / JVM lock / CPU lock / GPU / C2 lock, blah, 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 and there's an order to them. Okay. In H2O, I did ranks as a standalone thing, and then a lock could be out of rank, but the rank was known itself to be a rank because I had the thread pool per rank. so that if you came in at a rank and you were going to block, but somebody else came in and they needed a thread at that rank to run, the thread pool would pile in and kick off another dude. So there was a per rank thing going on in H2O, separate from the per lock. Yeah, lock ordering. Da, 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 da. Yeah, there you go, Matt. Boom. Partial order sufficient, right? Yeah. I think in Sun Codebase we did a total order because it was hell a lot easier. Because you just, if you wanted to know you were out of order, you just did a index check. If X less than Y, boom. And it found and fixed a lot of tricky bugs in the early hotspot JVM. I give full credit to lock ranking for sorting out a really ugly situation. You're trying to sort deadlock by spawning threads. I'll claim from my H2O experience that that could lead to an infinite thread launch problem. So you should start by throwing down an assert that says, I think if I spawn 100,000 threads, I'm just busted and something's wrong. And start with some ridiculous cutoff limit and go. And if you hit that cutoff limit, you got to rethink your approach.
The route that I took there is each thread, like in order to be running anything, you have to have a permit. And when you block, you give up your permit. And then if I have this background thread that's looking to see, does it look like the system is deadlocked? And if it doesn't, it finds someone like, oh, here's a thread that's from the JVM perspective, it's blocked, but from my framework perspective, it didn't mark that it was blocked. Then I will, so which means it still holds my permit. So I'll steal the permit from it, right? And I'll inject a new thread that now has that permit. Right. So this other thread, when it wakes up and it sees that it doesn't have a permit, it's no longer able to have like deadlock corrected for it. Its job is just to like get out as fast as possible. So that was my belief to how I would avoid having endless threads. Okay, but it went to sleep. Yep. Without giving up the permit. Why is it going to check the permit when it wakes up? Well, at some point it will check the permit again, not immediately when it wakes up. So, right, so it wakes up and now we've got one more thread than we're supposed to. But if it gets to, say it eventually gets to some place that it would block and like tell me about it, right, I can't now compensate for that thread. It doesn't have a permit. So while it would want to say, please spawn another thread because I'm going to block, instead it's like, I can't be counted for anymore. And eventually when it finishes its task, then that thread disappears. Yeah. In the land of Dudley fork join, there's a callback you make that says, I may block, I will block. Yeah, I looked at that and played with the fork join pool, and that was interesting. Like there, the fork join pool just seems to add threads endlessly, and yeah, you get all of a sudden, you only block 10,000 threads. Right. No, that was the bug fix I was talking about, where I started with an assert that said, if I hit some stupid limit, I'm stupid, stop. Right. and it seems like I dialed it down. Seems like to fix my bugs. In the fork join pool, it seems like if you block, so you have to use their managed blocker stuff. If you block on a managed blocker, it adds a thread. Right. But like that thread doesn't like go away in any sort of reasonable time frame, and so you can just have this absolute explosion. The approach I took on myself, when I go to unblock, I have to reacquire a permit, right? So unblocking isn't a free operation. It's like, oh no, guess what? You have to wait around if there's not a permit available. So the actual total number of on CPU threads stays, bounded. So I fixed the managed blocker side by claiming, by doing the lock ranking, and if he did spawn a thread, he would time it out after a bit and throw it away. So there, I put a cap that was only double the standard. So the norm was CPU count. I eventually ended up with a cap that was double. But that was all I needed. And prior to getting the bugs out, I would have exactly what we're talking about, thread explosion all the time, happen, boom, boom, boom. Okay. But somebody wouldn't block because of the lock ranking. They would not block unless they were guaranteed that somebody else was going to make forward progress elsewhere. And they didn't themselves need to make forward progress except to have somebody else in the current pool also make progress on more tasks in the current pool that the guy who was about to block couldn't do himself directly, because those other one is fork join. You just grab something from the pool and carry on. So you had a pool task that had a managed block in the middle. If everybody grabs the managed task and they all block on the managed task,
why are they blocking? Well, they're waiting for somebody at a higher level to make forward progress. Well, I'm going to have as many threads at the higher level guaranteed making forward progress as my CPU count anyhow. So I don't want to block a bazillion here. I only want to block CPU count. And the next guys at one rank up get a CPU count's worth to make their forward progress, and ad nauseum. And the only tricky business is I had blocks that would cross a cluster. And there I did not, in fact, want to span a million guys who were all waiting for hodgepodge across the cluster to come back, because it didn't do any good. So once I had launched off more than the node count of the cluster of remote tasks, there wasn't much point in doing a whole lot more. So it's whatever the latency throughput to another node count. So I had a scale on the node count for some ranks I would let threads get launched at. Those were always given the very highest priority. And so even though they could, in theory, spawn node count times some constant factor in practice, they rarely went above like 4 or 5, because I only ever handled them as the highest priority thread in the remote node, who immediately took it, ran, and non-blockingly didn't answer and returned it, right? There's a rare cases where this guy asked that guy, who then had to ask that guy, who then had to ask that guy, and you went up a rank at every tier going around, and pretty soon you were guaranteed to be quick, you know, UDP packet nanosecond turnaround times, and that was it. So I didn't need to have huge counts at in between guys, and it didn't do any good to do it anyhow, because there wasn't any more throughput to be had. So on one node, I'd say you should be 2x CPU count. Get your bugs out. So if you put it too low, you'll break all the time. But you should, with ranking, get away with no more than CPU count per rank, or CPU count times a fraction per rank.
Okay. That's still, I'm not quite getting how that is the magic number for the maximum thread count. It seems like you could certainly have an application that blocks a lot that would benefit from a larger pool.
If a blocking thread is blocking for a remote, not local resource, a remote resource that has throughput that's higher than latency, then you want to block with a fucking Little's law. You want to block according to the count of threads that you can max your throughput to the database. If you have threads that are blocking for a local resource and that lock is completely swamped, doesn't matter how many threads you lock, you're running that resource as max throughput, and more threads ain't helping, right? And now you should do lock breaking, right? You do striping the lock, you do CAS or non-blocking algorithm, whatever, you get rid of the fucking lock. But if that's not your case, you have some stupid, this thread's blocking that thread. Okay, that thread better be making forward progress. Okay, that thread blocks because he's blocking the next guy. Well, he better be making forward progress, right? If you don't close that cycle, you're deadlocked. If you don't close that cycle, it tops out. Okay, if it tops out, all the guys in between didn't help you, having lots of them, because they all block waiting for the next guy on the line. And the top guys better have as many threads as cores, because they're going to be churning resources for the lower level guys to keep feeding them issues to go deal with. Is that
okay? Yeah, I think I'm catching enough of that.
Okay, so it's like there's a fun thing about queuing theory. This is semi-related, fairly related queuing theory. Like, what's the purpose of a queue? It's to buffer latency between tasks flow in and flow out. Okay, the typical answer for queues, though, is that the producer beats the consumer and the queue is always full, and therefore you must have back pressure. Or the consumer beats the producer and the queue is always empty. You don't need a fucking queue in the first place. The consumer just deals, right?
Yeah, there are only 2 numbers in software. Well, 3 numbers, 0, 1, and infinity.
Infinity. Yeah, exactly. Right. The queue is either 0 or infinity. It, rarely for a little while it's 1, and then it's back to 0 or infinity. So in the case of this lock ranking CPU count thing, effectively you're looking at queues going up the food chain, and once the queue has 1 in it, it doesn't need another one, because the next guy, until the topmost queue is as busy as whatever your burst rate gets him, and he better not be blocking, and he's making progress, and everyone else is just feeding into him, and doesn't help if they feed more than he can throughput. So once the top ranks, they're not getting blocked, the unblockable guys are making forward progress, you don't need a queue that's any deeper than your CPU count, because they're not going to make any more progress than that anyhow. So you have back pressure.
Okay, that makes sense.
Okay, so your back pressure is your queue got full. Well, in this case, back pressure is your lock rank got full. Same thing. You're running back pressure down to stop the guys at the lower end of the back pressure. at the lower end of the food chain saying, don't feed me no more work because I can't deal with it anyhow.
Okay, yeah, that makes sense. Interesting.
Okay. Okay. Oh, here we go. Deadlock prevention. Yeah, linear ordering of resources. That is lock ranking. And that is probably a classic paper then on lock ranking. How old's that paper? 68. Yeah. Yeah, lock ranking been around the block a while. So that's it, Matt piling in. Cool. Anyone else? I'm about to call victory here. Okay, I'm gonna call it. See everybody next week, including detached head Cameron.
I won't wear a green shirt next week.
All right. All right.
That is unnerving.
Yeah, it is. It's a little disturbing. Yeah, beats having your head coming out of the mud pit in the ground with mushrooms and purple worms, blue worms.
I got a new cheap webcam for teaching this term whose color balance is basically unadjustable. And so even though I do have an actual green screen behind me, it overcorrects so badly that I basically look like a piece of rhubarb or something. I turn essentially like
turn on your video and let us see.
Oh, man. I've had a haircut since the pandemic started, so let me just cover my filth here and let me do that.
See,
Yeah,
this is my mullet in progress because I keep coming my sideburns, but not my back.
How long's it been, Cliff? It's been about almost 300 days for me. Oh, wrong camera. Let me switch cameras here. Switch cameras to the one that has the problem. See, the camera that actually has reasonable color balance is on the correct side of me.
Yeah, I see.
So now if I flip back to the radioactive one. Oh, actually, see, I'm kind of just jaundiced today. But like the alternative to that is I get like this horrible like red metamorpho face like some DC Comics creature.
I'm recalling an old newspaper comic where the guy was talking about being not in the sun and computer programmer and no tan and lighter, and then he's getting the reverse tan cream, and then now a new minty green, up from paler shade of white to minty green.
You think it would be able to work with my deathly green Seattle pallor a little bit better, because I'm kind of grayish to begin with. So, I should be as neutral a foreground object as one can imagine. And this was after my attempt to fix the horrible purple problem. And so now I've just got weird jaundice, simulated jaundice.
Planet of the Apes.
It's in keeping with the spirit of our times. It's funny, your reference to oh dear, that is ominous too. Your comment on Little's law, like that really ought to be taught in more places than just queuing theory classes, right? Like anyone rubs up against concurrency, because I would see this with like customer escalations I'd get pulled into all the time, where people would literally be using message-based middleware without the recognition that this system is most happy when most of its queues are mostly empty most of the time. And if something is outlandishly large, if it's growing, that's bad. And if it's outlandishly large and growing on top of that, those are also bad, right? Yeah, and you just misbudgeted something, right?
Right.
Or your system changed its behavior in some way.
One of the great wins of the TCP stack is to say infinitely depth queues are bad. Don't do it. Fucking do back pressure as soon as you get beyond some small depth, because you ain't improving your throughput by having an infinitely deep queue.
Well, so every time you lose a packet, you drop your throughput by 50%. That's the algorithm.
Also, even for the simple MM1 system, right, which is the most naively sort of stupid model you can actually still call a queuing model, right? Like people always assume you want super high utilization all the time. If you're not 90%, 95% utilization all the time, you're just leaving resources on the table. Never mind that the response time formula has like a 1/1 - rho or whatever in the denominator, so that you get to like 60% and suddenly you've got started climbing the hockey stick on delays, right? And it's like, why is my system? It's so active, it's so utilized. Nothing's getting
so slow.
Yeah, like just even knowing the shapes of those formulas, and it should pop up in like far more places than it does. Because it seems like the standard number of people coming through CS programs who actually looked at queuing theory at all is close to 0 on average, right?
Now, Jerry, you're a professor?
I'm sorry? No, I do a little bit of part-time teaching, but I'm other than that just kind of an industry deadbeat. But I quit VMware in disgust about 2 weeks ago, so now I'm part-time teaching slash disheveled hobo is my current status.
Oh, excellent.
Well, welcome to the world of not working in a big company.
Yeah.
Yeah, or for that matter, barely working at all. I'm kind of hoping that after I scrape off some of my carbon, I'll start playing with some stuff and maybe find something that involves a computer entertaining again. But it was kind of grim there towards the, well, I was going to say towards the end, but really it went on for several years. So what really is the end?
Which group are you in?
So I was a piece of VMware that was cast out to form Pivotal a few years back, and if you're lucky, you know nothing about that. But it was a horror show beyond words. Just it was imagine someone tried to build Jonestown in a daycare center, right? And that's kind of the corporate culture that they wound up with. It was sort of juice box Jonestown, and I was kind of in a marginalized side corner of that, and it was terrible because it was a Franken company made out of various botched VMware acquisitions that they decided to carve off, sweep into a mound and try to IPO independently, sort of the way EMC had IPO'd a piece of VMware after buying it years earlier, except the difference being that VMware had a cash cow business built around at least a temporarily defensible technical advantage, whereas 99% of Pivotal had none of that. And then as time went on, it just flopped and floundered, and every year was reinvented despite nothing ever really changing. And I think what happened was they tried to build these self-licking ice cream cones of shipping broken software. Then on top of that, you just send an infinitely large garrison of agile consultants to gaslight the customer into believing the broken software is not working for reasons that are the customer's fault. And then you just repeat as necessary. But the danger is that the stupidity depth of the customer might be bounded, and they may catch on at some point. And that was starting to catch on. So
I worked at a pig farm, so I know the idea. So.
what a lovely analogy.
No,
Josh Block was berated
it's a joke. It's there's a guy's driving along in the country, and he's got his BMW convertible, and he's driving along, and suddenly his car dies, and he pulls over to the side of the road, and he's like, I'm in the middle of nowhere, no cell signal, what am I going to do? And he sees a farmer in the field plowing, and he waves him down, and the farmer, on his tractor, and he says, my car broke down, and can you help me? And the guy says, sure, here, hop up on the tractor, we'll go back to the farm. And as they're approaching the farm, the wife's coming out of the farmhouse, and there's a pig kind of trotting along, but he's got a stump with a bandage on it, right? And the guy asks the farmer, he's like, wow, three-legged pig, I've never seen one of those before. And the farmer says, well, yeah, that pig's special. He says, really? He goes, oh yeah, that pig, I tell you, a year ago, Ma and I were sleeping up in the farmhouse, and farmhouse caught on fire, and we would have plumb slept right through it, except that pig came running up the stairs, broke down the door, ran up the stairs, grabbed us by our pajamas, pulled us out of the house, saved our lives. That is a special pig. And he goes, oh wow, did it lose its limb in the fire? And the farmer's like, no, didn't happen in the fire. That's a special pig. I tell you, last spring I was out plowing, and it was raining, and it was all muddy, and the tractor got in a rut and fell over on my leg, and I was pinned. I was going to die for sure. And that pig, he saw it happen. He came running out, and he pulled me out from under the tractor. He saved my life. He did. And the guy said, oh wow, that's amazing. Did it hurt itself, pulling you out from under the tractor? And the farmer goes, no, that's a special pig. And the guy said, well, how do you lose his leg? The farmer looks at him a little weird and says, well, you got a pig that's special. You're not going to eat them all at once. Yeah, I worked at Oracle.
Yeah. So yeah, I imagine you've been on that occasional escalation call where they decide that someone more serious than the people who normally handle these has to show up, and then you realize you've just, maybe you haven't, maybe I'm projecting, you realize that the customer has been told so many lies in advance of your getting there that you're now in this horrible maze of twisty passages where you have to somehow try to help them with their root problem.
My NDA will not allow me to answer that question.
My MBA will not allow
yeah.
No, NDA, non-disclosure.
No, MBA.
Yeah, I had a teacher who used to say that intellectual honesty had at least 2 obvious prerequisites, and like when you get pulled into these sort of carpet scenarios where one or both are just woefully absent, it degrades the soul.
I finally put my foot down on getting in those and demanded better out of my startup cohorts.
So
I got my share of those too.
Jerry, what kind of compiler work you doing?
Presently, basically nothing. In the past, I worked on the R statistics language, the sort of waning company that was the commercial backer of S+, the language it descended from. Years ago, they decided that they needed it to actually perform better than a scheme interpreter of 1979 did. And so I worked on basically porting the R runtime to generate JVM bytecode and then to take advantage of JVM optimizations below that. And you could get easily 1,000 or 10,000 X speedups in some cases because the interpreter that S+ ran on was actually worse than the one R ran on. The one that R runs on at least looks like it's from the early 80s as opposed to the late 70s. And so that sort of pulled me into the JVM languages orbit. And I'm sort of in an extended orbit around it now, where my interest in it has never waned to zero. Even if you're not actively working in it, knowing what's going on in the platform and lower level details always helps you with whatever you probably are working on if you're anywhere near the JVM. So I've tried to never get too far away, but even if I'm at some horrible upstack middleware distributed ding McDoodle level.
Cool.
All right. Well, now we're at about 2-hour mark, so I'm going to call it. And hope to see everyone next time.
Yeah, thanks for putting this together, Cliff. I didn't throw much in because I was kind of half distracted with another thing I was paying too much in the background, but I very much enjoyed tracking and listening. And should you do one of these again and be willing to tolerate the lurking,
yeah, this is a weekly thing for months now.
Oh, okay.
So you'll get an invite till you don't show up too many times in a row, and then I'll throw you off the list, and you can just ask to get back on. But
okay,
what you're looking at
sounds good.
are the regulars, and then we always have people drift in and out.
Yeah, because with the pandemic, basically, I'm doing part-time teaching at UW. There's a system seminar at UW that I Zoom into, and I usually do that on the treadmill. So other opportunities to not go completely feral by having no social technical contact are welcome.
That's where I'm at.
We can definitely use the humor.
Yep. All right. Next week. Bye-bye.
Stay safe, everybody.
See you.
Bye.